Well, hello friends, welcome back to Browser Hacking. Today we're just going to continue where we left off yesterday. So yesterday we were tokenizing. Today we are going to try to build a tree out of the tokens we were producing. So since last video I was doing a little bit more work on the tokenizer, but nothing very crazy, just filling in some of the missing states, stuff like that. Now there's still plenty of states left to implement, but I was just fleshing it out a little bit. And the most important change that I made is that character tokens are now accumulated fully instead of producing like one token per character, because it just seemed kind of silly to keep accumulating, or to not accumulate characters into a blob instead of sending them out like that. Anyway, so let's see if we can get the thing here so I can show you. So if we just look at the welcome HTML page, for example, we can see what the output looks like now if we take a bigger page. Actually, let me use the page I was using yesterday, the simple page. So that's that's this one. I added like a little meta tag to it, so we can see that attribute parsing works as well. And I added attribute parsing yesterday after the recording, but nothing big or crazy. But basically now let's move on to tree building or parsing. So let's bring up the spec right here, and let's see what it says. So tree construction, sure. Wait, hold on. Parse state. So I'm thinking let's make some kind of parser class that can sit around the tokenizer. And maybe we'll call it something like, we already have HTML parser here, which is the name of the existing parser, but maybe we can call this something else temporarily or whatever. We call it like the HTML tree builder. I think that's okay. Or actually, that's kind of weird. Let me call it the HTML document parser, because that's what we are going to do now. We're going to parse a document. Okay, so now that we have gotten that difficult decision out of the way, let's add it to the CMake lists. I guess I could have just renamed this to like legacy parser or whatever, but yeah. Okay, so the document parser has a state. So it's in an insertion mode, which is a state variable that controls the primary operation of the tree construction stage. So this is our parser state. It starts out in initial, and then it has these modes right here. So let's just wait, what just happened? HTML tokenizer has been removed from disk. And oh, damn it. I thought I was just removing the tree builder. I was doing T asterisk. Okay. Let me undo this silly mistake. Okay, so HTML document parser. Okay, so let's put that in the web namespace, and we'll call it the HTML document parser. Now this is going to be our big boy parser that does the all the good stuff. And we're going to have these states right here. And these are few enough states that I don't have to do that fast forwarding regex hack that I did yesterday. Let's see how many we have here. Actually, there are a few. Yeah, I thought they looked fewer in that list. Okay, wait, hold on. No, we can handle this. Can we handle this without fast forwarding? I feel like we can. It's not that big of a deal, right? Before HTML. Before head. In head. In head, no script. After head. In body. Text. In table text. In caption. In column group. In table body. Row in cell. In cell. Jeez. They're everywhere these days. After body. After boy comes what? Hope not incel. After frame set. And after body. After frame set. And that's basically it. Alright, so these are our states. Now let's do the same thing we did for the tokens. Let's do a simple enumerator macro here. Enumerate parser states. And enumerate parser state. Okay, so these guys we will just say dun 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 dun. And okay, I wonder if I could have done that thing yesterday this quickly. It was too many of them. I don't know. Wait, where are my backslashes at? There we go. Look at that. I really enjoy using these enumerator macros. They just make this obnoxious stuff a little bit nicer. Oops, that's not what I meant to do. Define, enumerate, parser, state. Okay, great. Then, finally, we'll be starting in the, what was it called? Initial state? Oh, that wasn't part of the list. Okay, so we need an initial state as well. That's the magical initial state. I guess you can't go back to the initial state, which is fine, probably. Okay, so this is our parser, and what do we need to know here? So the insertion mode, maybe this shouldn't be called parser state, but rather insertion mode. Let's see, parser state insertion mode, because I guess parser has more state than just the insertion mode, right? So insertion mode. Mode. All right. So the parser has more state than this. Several of these modes are special, blah, blah, blah. Yeah. Let's not worry too much about this. And here are some algorithms that we need to refer to in the future for sure. Look at that, it has 18 steps. That sounds obnoxious, but I'm sure it's understandable once we get to the point where we have to understand it. So this is state part 2, the stack of open elements. Initially, the stack of open elements is empty. The stack grows downwards, so the topmost node on the stack is the first one added to the stack. All right, so it's just a stack of DOM elements, essentially, that we are currently building. So I think the easiest abstraction for that is just a vector of a non-null ref putter vector of nodes. And for that we will need the famous libweb doom node class. Okay, so this will be our, what was it called? Stack of open elements. And I guess we'll also need the non-null ref putter vector. Okay. Maybe we can expose this. I'm not sure why we need it, but now we expose it. We might want to, or I don't know yet if the tokenizer needs to look at the parser's state. I think maybe, I'm not sure. The parser certainly needs to be able to fiddle with the tokenizer. So I think we're going to make it so that the parser, what does he do? He will drive the tokenizer. So let's have something like, the thing that we want this whole shenanigan machine to produce is essentially a ref putter to a document. So say parse, maybe not static, but parse, yeah. Say parse, or I don't know how I want to organize this. Like, how would we use this in our test program? So we have the HT program, this little testy thing, which currently just creates the tokenizer. So I think we will instead create a document parser, and then we will do something with that. So parser of contents, and then we'll do parser run, I guess. So kind of different from what we were doing yesterday, but not different at all. So that's cool. And then we'll put the tokenizer in here. I think that will be fine as a first step. Web parser HTML tokenizer. Wait. Tokenizer. Yeah. And then when you construct one of these guys, you provide the string view that we get our input from. So input. And we totally skipped over like character encoding detection, because there's this whole part of the parser spec that is concerned with like how do you determine which encoding the input is. We're just skipping over that and assuming everything is ASCII right now. And then that's something that we have to sort of adapt to later. But there's plenty of stuff to do where we can just assume ASCII without that causing us to write code that is not transferable into the future. So it doesn't really matter at the moment. So that looks sane. And then I guess, yeah, so we'll just have the run helper function here for now. This one it's mostly for our test. And then when it comes to the tokenizer though, like now we don't just want him to run, we want him to give us a token. So I guess that would be an optional HTML token. Next token, or maybe even just, well, next token is pretty good. Yeah, and if we run out of tokens, so then we'll give you an end of file, but then if we've done that, then there's nothing left to give you. I guess at that point we have to return an empty optional. Yeah, we'll figure out how that works and how to return them. We'll get there. But next token, okay, so then Let's go in the document parser class and maybe invent some of the implementations of these things. Because now I feel like I sketched out a little class there. And maybe we can do something with that. So here's our input. And I didn't call it that. Oh, actually, we can just pass that straight to the tokenizer. We don't need to store it anywhere. Cool. And then we have the document parser run. Okay. So here, we'll do an infinite loop. And then we'll say token is tokenizer next token. And if the token has no value, so it's an empty optional, then we will return. So we'll return when we run out of tokens. That makes sense. And then comes the parsing, I guess. But maybe we should get to the point where we can actually run this loop. So let's see. In the tokenizer class, we had this thing that would print out the token. So that was the emit function. Now, whenever the tokenizer spec was saying emit a token, what he really means, I guess, is that that's what next token should return. So when you're calling, you're not going to be calling run anymore. This really needs to become next token. Right, and then run basically needs to have a sad but necessary def, and next token needs to become about returning the token. So whenever we say emit current token, that becomes return the current token. So what does emit currently do? It just prints out the contents of the current token. So I'm thinking what we'll do here is we will return, and we'll say emit current token. We'll go for this domain-specific language here. Although now, if this causes us to return, then we can't switch to afterwards. So if we're doing an emit and switch, but the emit is returning, then we need to, the switch is not going to be a go-to. We just have to update the state. Yeah, so we'll switch to, how does that work? So we'll switch to, yeah, so this is part of the character accumulation thing that I mentioned, that basically when we are processing something that goes into a character token, then we just append, let me see if I can show you what that looks like. Where are you? Which was one of the, oh, maybe it was just a data state, like the very first state. Yes, right, it's the very first state. So if the current token is not already character, then we create a new token. But if the current token is already character, then we just append to that token. And that means that we are accumulating characters in the current token until we get to the point where we want to return or emit, and then emit current token. Or actually, no, that's not how it works. The way it works is that when we do a switch to or a reconsume in, then we call these helpers will switch to and will reconsume in, and they flush the accumulated current character or comment token if needed. So here you can see that if we are accumulating characters or comments, then emit token. Anyway, just wanted to explain how that works. So now, when we say emit, eoff, and return, I guess that really just becomes eoff. Emit, eoff, because emit is always going to be a return at this point. So emit, eoff, and no. So emit that token. Return mCurrent token. Should we do it like that? I guess it doesn't matter. Okay, and then we can have emit current token. Return mCurrent token. Does that make sense? Let's see. So wherever we're doing emit current token like this, instead we would just say emit current token. So what did it say in the tag name state for greater than sign? Switch to the data state, emit the current tag token, right? So switch to the different state and emit the current tag token. Okay, you go. State data, emit current token. This one is a bit awkward because I want to say switch to like this, but then it will go to that place. Switch to, should we do them in a combined thing? Switch to and emit current token. We can do that. Switch to and emit current token. New state, switch to new state. Or rather, actually, we'll switch to state, new state, and state is state, new state. But we don't go to it. Instead, we will return mCurrent token. So this can't work this way anymore. I realize now. Flushing the lazily accumulated token has to be different. Dang it. Okay. Well, maybe we can avoid worrying about that right now, and then I can get back to that later. Let's see if we can just get this thing to build here. Yes. But we need to get rid of the emit function. Emit current token. So switch to and emit current token. Yeah. Oh, they're all like that. Okay, I should just copy this. Okay. And then this here is more like a stringification for a token. So maybe we can put that in the HTML token CPP file. Oh. HTML token, and we will call this one to string, maybe something like that. And we'll say return builder to string. Okay. And then we'll add something here, string to string const. And then this just becomes a matter of deleting a bunch of these. Oopsie doopsie. All right. There we are, and then let's ignore this problem for now. And in the parser, whenever we get a token, we will do debug. I guess we should log the state, or the insertion mode that we're in. So insertion mode name. And the token to string. Oops, actually it needs to be that value to string. Okay. And the insertion mode name is let's just add a helper for that. Enumerate insertion mode. Case insertion mode turn mode. Great. So, can we get this to work? I messed something up here. Data state. Nobody jumps to it anymore. Oh shit. Switch to and emit current token. So nobody's gonna go to there. How do we make it not complain about an unused label? We're probably eventually gonna have some use for it. But I think maybe right now I will sidestep this issue by adding a no unused label warning removal thingy. Oh, and then we have to rebuild everything, of course. Anyways, let's go and take a look at the document parser while it builds. So I guess tree construction, wait, yeah, whatever. Let's go here. The initial insertion mode. When the user agent is to apply the rules for blah 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 spec language, then we have to do this with the tokens. Okay, so our first token, hopefully, is going to be a doc type token. So if the doc type token's name is not identical to HTML, then there's a parse error, sure. And then we append a document type node to the document node. Okay. So I guess we need to start out with a document node. So we'll do that here. We'll make our very own little document node. Wait, no, we already have that included. So we can, how do we create that? Just adopt. New document. I thought I had included it. Okay, there we go. So maybe we should have that as a member, actually, because yeah, let's do it this way. Okay, and then, oh, we have some failure here. Document parser, line 35. Oh, you just gotta end that namespace properly. No big deal. Right, so what were you saying? So when we encounter the doc type token and we want to append a document type node to the document with the name attribute set to the name given in the doc type token, or the empty string if the name was missing. Right, so let's do that. Document type. All right, so here, imagining that we are in this kind of mode, so case, or actually let's do an if. Insertion mode is insertion mode initial. If token, I kind of want to shorthandify this thing a little bit, so let's say token optional token, or, and then we'll do something like auto token is optional token value. So then we can just refer to it as token from now on, which will be a lot nicer. Okay, so if it's a doc type, oh, where are we now? HTML document parser. Oh, we need an out-of-line destructor. Otherwise, it can't see the destructor of the DOM document. No big deal. Okay, let's just close that. All right, so append the document type right to the document. We'll call it doc type is doc type. Doc new document type for document. Doc type set name is token, and then we need to reach into these name to string. All right, so let's make the token be friendly with the document parser. So it's already friendly with the tokenizer. Okay, and then doc type needs a set name function. Set name. I don't know, something like this. So how would that go? We still can't build? Oh, we could. Okay. Let's see if we can actually run this. That's a crash. All right, so why are we crashing? A null dereference in the document constructor. I guess. Oh, document assumes that that we have an event loop. That's a bit weird. I guess because I never used document outside of program with an event loop before. Let's just have an event loop. It simplifies this problem. event loop. We don't have to actually run the event loop, we can just instantiate it, and I think that might be enough to make that problem go away. Okay, so now we're in the initial state and we're getting the end of file token over and over and over. Here's our doc type. So for the end of file, I guess we can just bail when we get the end of file. So we'll do something, we'll dump out the token that we got, and then we'll say if token type is end of file, return. Okay, and then let's dump out the DOM that we were able to produce. So this thing maybe should return the document, or have a way to show you a document. How about this? Just like that, and then we'll get libweb dump document is parser document dump tree document. Will that work? That doesn't work because we don't know what a document is. But if we did, it would work. Yes. And then we need to actually return it, but that's the easy part. Oh. I don't know what happened there. Okay. So this is our document. It is very empty, but at least we have one. So I guess here we need to actually insert the doc type into the document. So what did the spec say? Append document type node to the document node. You got it, dude. Okay, let's see if this actually works. Didn't work, dang it. Let's see, so we're logging the insertion mode name and the token to string. So we are here, initial insertion mode with a doc type. So we should really get here. It is weird if we don't. So let's see. Adding doc type node in initial mode. Name is doc type name. Oh, he's right there. Wait, did I not? Maybe I didn't rebuild or something? I don't know. Anyway, so that works. That's great. So this is our DOM now. Magical. And then I guess we should just follow the steps here. So append the document type node. Blah, 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 blah. Associate it with the document object. Yeah, we already done that. So that it is returned as the value of the doc type attribute of the document object. I think maybe we don't have a way to, well, we don't have that on document right now, but it is bound to the document. When we construct the document type, we give the document pointer to the constructor, so that should be good. So let's see, then if document is not an iframe source doc, and the doc type token matches one of these conditions in the following list, then set it to quirks mode. Quirks mode. So then there are all these reasons that we would go into quirks mode. If you're using all of these adorable old doc types, look at that, Sun Microsystems hot Java HTML. Amazing. So let's just bypass this stuff because we don't have quirks mode anyway. And then blah, blah, blah. Then switch the insertion mode to before HTML. Well, we can do that. So I think here the trick is to just say insertion mode is now insertion mode before HTML. And unlike the tokenizer, I think here we're not going to need to awkwardly jump between different insertion modes. I think that awkward go-to case stuff is we can probably limit that to the tokenizer, I'm hoping. So here we would just do a continue. Now this is going to become huge if we keep doing it this way. So maybe this should be a helper. So document parser. I don't know, like we'll call it something like handle initial. This is like the initial mode, and then we would do that here. I don't know, that kind of makes sense to me. Because then we can just switch on the insertion mode here and call the appropriate function. Token, like that. Yeah, let's do it that way. So, handle initial, and then we gotta go to handle before HTML immediately after. And then assuming that after that comes, well, I already forgot what they were called. Okay, we got a couple of these here, so I guess we can add these guys. So handle in head, no script, after head. We can add more later, but we'll start with these. And here, let's see. This should just be a switch. Okay, let's do some really inspiring programming. Oops. For HTML. Insertion mode in head. Okay. And head no script. And then comes in body, right? And text. Alright, so we'll start with these. And then we'll have default, assert not reached, or yeah, that's fine. and then we'll just loop around to the next token. I think this will be good, because then you can just return when you process the token. Because if we do everything in this one big loop here, it's going to be really confusing. It's going to be really confusing how we get back to the next step of the loop, right? Because if you have like, if you loop in any of the steps, like a nested loop, then if you continue thinking that it's going to take you to the outer token loop and so on, you know what I mean. Let's quickly paste these guys here. Something like this. Clickety, oops. All right. Good enough. Now, finally, we are in before HTML. So what do we do in before HTML? So the next token we have, if we look at our token list, is going to be a start tag. So we're actually skipping over the character tokens now. So we're going to have a start tag token, and its name is HTML. So that's literally this right here, a start tag whose name is HTML. So in before HTML, if token type is HTML token. You know what? This is so tedious to write. Let's add something here, like is start tag. This is going to read so much better. Type is no, that's not what I meant to say. And tag comment character. Maybe I'm going to regret doing that character accumulation buffering thing. Because maybe it was easier before I did that, even though it was less efficient. I don't know, we'll see. The trick to doing stuff like this is to not get caught fiddling with the details too much, but instead to just motor forward and make sure that you make like macro progress. Because when you're implementing a gigantic spec, macro progress is the absolute most important thing to not get demotivated, I think. So you need to always be making some kind of high-level progress, which is what we're trying to do here. So this, I wanted to say if token is start tag and token tag name toString is HTML. Cool. Then I guess we can add a helper for that too. So string tag name, and here we'll assert is start tag or is end tag, and then we'll return end tag name to string. So we can write this like this. Very nice and expressive, isn't it? We need to get better at this type of stuff, like making sure that the code stays expressive, because this is going to get pretty big. Create an element for the token. Okay, so we have our element factory, which we can call now. So element factory knows how to create an appropriate C++ element object for a given element name or a given tag name. Where is that element factory? And I'll show you that quickly. So it's just a function called create element that takes the document and the tag name of the element, and then it just looks at the tag name and returns like a newly allocated HTML element object, basically appropriate for the tag name. So that's how we're going to do that. So we'll just call that one. So auto element is create element with our document, Actually, we can use the document getter here too. With our document and the token.tag name. Let's put him always on top already, okay. Create an element for the token in the HTML namespace. We don't have namespaces yet, let's not worry about that. With the document as the intended parent. Right, that's what we're saying here. Append it to the document object. Put this element in the stack of open elements. We can do all of these things. Document, append child, move element. Let's do that here too. Nice. And then stack of open elements, append, put it in the stack of open elements. You know, this, I feel like this kind of language could be a little bit clearer. You would say, because if it's a stack, you would say like push it on the stack of open elements. But we're not here to argue about the language of the spec, so we'll just append it to the stack, which means we can't move it like that. That's fine. Okay. If the document is being loaded as part of navigation of a browsing context and the result of executing is environment settings object a secure context, and blah 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 blah. If we are doing some service worker crap, I don't care. Otherwise, check for a manifest attribute, don't care. App cache stuff, definitely don't care. Switch insertion mode to before head. Okay. And I think we will start now reached in the end of these kind of functions so that we catch if we do something that we don't handle. Okay, so next step would be that we go to before head, right? The before head insertion mode. Oh, did I forget to add a function for that? I guess it wasn't in the list. Well, we'll just do these. Or wait, what did my document look like? I already forgot. Simple. So we have doc type, HTML, head. Okay, so now we're before head. And we want to get to b5 head. Handle before head token. All right. So, what do we have coming up now? Now we have a head tag, start tag, whose name is head. So we will be here. So I'm just skipping over all of the things that we're not. Just now we're gonna like cut through this specific path that this exact input takes. But then of course, to implement the complete parser, we have to implement all of these different possibilities. But for the video, we're just following a specific path just to see that through. So if the token is a start tag and the token tag name is head, over here, and then we do essentially, oh wait, no, hold on. It's not exactly the same as the other one, so create element, document, token tag name. Set the head element pointer. It doesn't say to append it to anything yet, so what does it mean? The head element pointer. Initially the head element pointer and the form element pointer are both null. Sure. once we have a head element parsed, implicitly or explicitly, the head element pointer gets set to this node. Okay. Oh, look at this. This is the form element pointer is used to make form controls associate with forms in the face of a dramatically bad markup for historical reasons. It's colorful language by spec editor here, who's clearly upset about something and expressing it in the tamest way possible. But you can just tell that he was mad about something. So let's see. So I guess we should have a head element pointer here. So we'll call it the HTML head element. And we'll also have a form element pointer. Seems fair. And let's forward declare that. Cool. So then we set the head element to what does this mean, by the way? Insert an HTML element. Yeah. Okay, well, whatever. I know what it means to insert an HTML element. It just means to... Wait, do I actually know what it means? Hold on, I'm getting ahead of myself. The user agent must insert a foreign element for the token. Okay, so I should probably pay attention here. So this is the thing that we're doing. Insert a foreign element for a token in a given namespace. Let the adjusted insertion location be the appropriate place for inserting a node, which is the position in an element returned by running the following steps. Wait, hold on. So let element be the result of creating an element for the token. So we've done that. We've created an element for the token, with the intended parent being the element in which the adjusted insertion location finds itself. Right, so we got to find the appropriate place for inserting a node. And then if it is possible to insert element at the adjusted insertion location, then if it's not a fragment parsing algo, then push a new element queue onto element's relevant agent's custom element reaction stack. Okay, so we're not caring about custom elements at all. Insert the element, and then if it's not a fragment parser, then okay, so custom element. So it's just find a place to insert it and insert it there. And if the adjusted insertion location cannot accept more elements because it's a, for example, because it's a document that already has an element child, right? Then it's dropped on the floor. So the document cannot have more than one element child. So the HTML element is the only possible child of the document, right? Other than, I mean, you can have the doc type, for example, but that's not an element node. You can only have one element child of a document. And then push element onto the stack of open elements, and then return element. Okay, so this needs to, this was like one way of doing it, I guess. I'm not sure why they were doing it so explicitly for this step, but here, this sounds more generic, so we should probably define this as a helper function, so something like insert foreign element, or actually insert an HTML element. But let's stick with these names that they're using. Insert an HTML element for the token. So we'll do this. And then we were supposed to set that. So I guess we'll make him return in the element pointer. Does that work? Set the head element pointer to the newly created head element, and then switch to in head. Insertion mode in head. Return. Okay, now we gotta deal with this thing. So, how do we figure this out? I'm thinking, should we have like it call a separate function that is called insert a foreign element? But that's just getting a little too ahead of ourselves, I think. So we got to locate the appropriate place for inserting a node. I think there was no override target specified, so yeah, it's just let it be the appropriate place. Otherwise, let target be the current node. Okay, so target is the current node. What is the current node? It's the bottommost node in the stack of open elements. Okay, so let's invent that for ourselves. That would be node. Let's use reference counting pointers for all of this. Current node. Stack of open elements last. So this will assert if there's nothing in the stack, but I think that's okay. So we could actually have it return a node amp because we know it's in the stack. Non-null ref footer to node current node. I'm going to write this defensively because I don't really know what kind of weird algorithms are coming up. That's why I'm using reference counting pointers and stuff. If I was confident that we would always keep it in the stack, I would just do this, right? But I have no idea where this is going, so we'll see. Oh, maybe we should make this thing actually return the elements. So it might fail, but if it succeeds, it will return an HTML element, I suppose. And head element is going to be 2 HTML head element. Will that work? I think that'll work. Maybe I have to start. Oh wait, that doesn't work because I have to include. Okay, that's good. So, where were we? Let target be the current node. Determine the adjusted insertion location using the first matching steps from the following list. Foster parenting is enabled. So I'm pretty sure that it's not enabled. So let's have a state for that so that we don't forget about this. Foster parenting, not enabled. And then what do we return for the appropriate place? I guess we return a node, presumably. Or a parent node, I guess. We'll return a parent node, which is a place where you can insert but let's make a special function for this as well. Because adding these functions will make it easier to understand what the different insertion mode handlers are doing, I think. So find appropriate place for inserting node. I wish they would express this as like a function that takes an argument, but I guess they didn't do that, so I guess I have to work out for myself what that is. Okay, so HTML document parser. Here we are. So we'll move this up here. And if foster parenting will assert not reached, so we don't know what to do with that. And otherwise, let adjusted insertion location be inside target after its last child, if any. Well, that was easy. So return target. And then it's just a matter of appending to it, right? And if it's inside of a template element, let it instead be inside a template element's template contents after its last child. We don't care about template elements. So, where were we? Find, right, the adjusted insertion location is find appropriate place for inserting node. And then let element be the result of creating an element for the token. Okay, so we'll do that after. And then fix me, check if it's possible to insert element at adjusted insertion location. And then we'll just insert it, which means that adjusted insertion location, append child, move element, or not move, because we're also going to return element. Push element onto the stack of open elements so that it's the new current node. Append element, return element. So I think I was a little bit eager here making this return HTML element, so we're just going to have it return element. But otherwise that's pretty okay. So that was the before head insertion mode, right? And then we switch to in head. Okay. So now if we've done this correctly, then we should have a DOM with a head element inside of the HTML. Let's see if that works. Oh, I need to actually include the form element. I heard from a lot of people that they really liked the first video I did yesterday about tokenizing, because that's really nice, because I do feel quite strongly about this, that it is so much simpler than people think it is, or so much more doable than people think it is. So it's really nice to hear that people can actually watch this videos and see that it's not so bad. Because it isn't. I mean, yeah, it's a lot of spec language, but you can totally do this. Okay, look at that. We progressed to in head, and this is our DOM that we've built so far. So let's just keep going to the end of the file. So what was our next token? It was a start tag named meta. So now we are in the in head insertion mode. So which one is this going to match? This one right here. A start tag whose name is meta. assert not reached. Okay. Then we're going to insert an HTML element for the token, so we already know how to do that. Insert HTML element for token. Immediately pop the current node off the stack of open elements. Okay. Stack of open elements. Take last. That's our pop. Maybe we should have a separate stack thing so that we can. It would be nice if we could say pop here, right? But since we're using vector, we have to use vector names. It's not super important. And then acknowledge the token's self-closing flag. When a start tag token is emitted with its self-closing flag set, I don't think we ever did anything in the tokenizer for that yet. If the flag is not acknowledged when it's processed, so I think we'll just ignore that for now, or we can check it actually. So is self-closing, and then we'll assert that it's a tag, and then return m tag self-closing. So if it is set, if token is self-closing, assert not reached. We can deal with that when we get there. If the element has a char set attribute, we don't. See, this is part of that thing I was talking about, by the way, for determining the encoding. So if you encounter a meta char set, then you have to change your tokenizing behavior at that point immediately. So anything you tokenize after that point has to process the input as if it's that encoding that you were told now instead. So it's pretty weird. Okay. And then, yeah, you can also get it from the content type HTTP equiv thing, but we are just inserting the meta as it is. I think we need to be a little bit smarter because this thing doesn't creating an element for the token. We need to copy over the attributes. Yeah, so we didn't actually look at this particular thing. Let document be, so this is the instructions for creating an element for a token. Maybe we should have made a function out of that as well. Create element for a token. Maybe it's the good boy thing to do, actually. Create element for a token. Or create element for will sound a little bit cooler. Create element for token. See? That's cool. And it was the same up here for token. So we're going to want to transfer the attributes. That's the main thing we need to do here. So I'm sure there's more stuff that we're supposed to do here. Like it might be time to execute scripts and stuff like that, but we'll do one thing at a time. So let document be the intended node document, blah, blah, blah. Local name is the tag name of the token. Here's the is attributes, but that's custom element stuff, more custom element stuff, fragment parsing stuff. No, this is non-fragment parsing. Okay, so will execute script can be true. Definition, what's definition? Oh, it's the custom element thing. Oh, never mind. Okay. Append each attribute in the given token to element. Aha. token, or no, attribute in token m tag attributes set. We have set attributes, which we can do, which sets them all at once. You can also call set attribute one at a time. I guess that works. Attribute name builder to string, attribute value builder to string. Cool. And then if we'll execute script is some custom element crap. XML namespace, we don't care right now at least. If it's a resettable element, I guess that's for like form elements that it can be checked and stuff. So when you're creating like a checkbox or something like that and you're supposed to do something, I think we'll probably skip over this for now. If it's form associated, let's skip over that too. So let's just do that. Okay. So can this fail? I guess it can't actually fail. So we should return non-null ref cover. Create element 4 because we always produce some element because we have a token and it's a start tag token. So we have a name and we can always make some kind of element even if it's not a valid name or like a recognized name. We can still give you like a neutral element. Okay, so we got the meta. It is meta. That's where we were in head, right? So we acknowledge it, and then I think we just stay in the same place. And we're gonna have an end tag coming up. So let's see. Oh, assertion failed. 144. So we didn't get to see the DOM. So we got here. Yeah, so we're still in head. Because now we have an end tag instead. This guy right here, end tag name head. So we just have to look through these different things. An end tag whose name is head. We can do that. So if token is end tag and token tag name is head, pop a current node. So stack of open elements, take last, pop it off of the stack of open elements, and then switch the insertion mode to after head. Boom. Okay. And then, oh, I guess we should probably assert not reached in these. At least until we implement them. Okay, so now we are after head, right? After head. Okay, and what comes next? I guess we need to compile to find out. Because now that it asserts, I don't see the rest of the tokens. Alright, look at that. It's our meta tag here inside of the head. Very cool. And then we have an end tag for the HTML. So an after head, can we get an end tag whose name is one of body, HTML, or BR? Act as described in the anything else. Okay. So let's do that. If token is end tag and token tag name is one of body, I guess we can say this in some... I'm just going to write it out in this goofy way, and then we'll let client format deal with it. Okay, that did not turn out so beautiful. Oh. Wait. Maybe that's not so bad. This is something where I wish that maybe it's not that I wish that, like I wish I could express this in a more terse way, and maybe I can if I actually take the time to make a little helper for it, you know? Like if token tag name in is one of, that would be kind of a cool API. HTML, BR, something like that. But we don't have to get carried away with that right now. Let's stay on target. So, act as described in the anything else entry below. So, that's a bit weird that they like call this out specifically, but then they say like do this. Like why couldn't, I guess they could like omit this and it would make no difference, right? But maybe it's specified this way for some reason. So what we're going to do is insert an HTML element. So we could do a go to anything else here. It's a little bit bizarre, but maybe this is not a terrible idea. Insert HTML element for a body start tag token with no attributes. Oh, so now we have to fake a start tag token with no attributes. Fake body token. And we have to set this up manually. So fake body token and type. No attributes. Fake body tag name append body. And insert HTML element for that fake body token. And then switch to in body, and then reprocess the current token. Oh, interesting. So insertion mode is in body. I guess return at the end here is kind of pointless. So this makes me feel like, now that we're saying, like, this is like, if all else fails, this makes me feel like it's not right to not spell out all these other conditions, so we're gonna do that. If token is character, so if it's any character token, then we will assert not reached. I'm just gonna do these so that we at least catch this. Comment, doc type, after head, if it's a start tag, and token tag name is HTML. If it's body, and then we got frame set. And then we got that one. Ooh, that's a huge number of different ones, but I guess we gotta deal with this. So we got base font. So many of them. Maybe we can do it this way. Or can we do it this way, maybe? Names. Hold on. What if we do it this way? Does this work? Contains token tag name. That kind of works. And then, yeah, we should do something nicer for that, but I'm not going to do it now. So we have those, and then we have template, an end tag whose name is template. An end tag who is one of these guys. That's cool. Don't go to anything else, and then a start tag whose name is head, or any other end tag. Or token is end tag. So now reached. All right. Finally, I think maybe. Look at that. We inserted a fake body. So this is basically a very, very small version of how the automatic fix-up of broken markup works in browsers, right? So basically, if you go to a website that has like incomplete or inconsistent or like bad HTML somehow, then the HTML spec very clearly defines how this fix-ups occur. And this is one example of that. And I think that's pretty neat because if you parse HTML in an ad hoc way, then you kind of assume that a lot of what goes into it is figuring out how to fix all these annoying like mismatched tags and things like that. But you don't actually have to figure that out for yourself. If you just follow these rules, then it's going to work out in a consistent way that will be consistent with existing browsers, which is exactly what you want. So that's pretty neat. So that is our thing. So let's commit. Because now we can actually tokenize and parse that whole thing. And I guess we can do a little bit of extra stuff here separately. Libweb, add document type main field to the document type object. Okay. To document type notes. Yeah. And then here we would just, I think we were just adding the head element to, no, form element to the forwarding header. That's fine. And then it was just a big change. And this guy here was a bit of a hack. Turn off that warning. Let's turn that off locally instead, because that's really silly what I was doing there. Was no unused label. So we have diagnostic ignore. There's some way to do this. Yeah, pragma GCC diagnostic ignored. Tokenizer. So right here, we're just gonna Pragma GCC. I think Clang will understand it. Actually, we're not even building this file with Clang anyway, so it doesn't really matter. And it was unused label. And then we can remove that from the CMake files, CMake lists. And then we can do a monster rebuild, although it will be fast because of Ccache. So we'll add this, that, this, and oh, and we're gonna need copyright headers for everybody. Yeah, there we go. libweb. Start, continue, or add, start building the parser part of the new literature tree building part of the new HTML parser. Okay, and here we can see that it totally works. Great. This patch adds a new HTML document parser class. It internally keeps a tokenizer object internally and feeds itself with one token at a time from it. This the names and idioms in this class are expressed as closely to the actual HTML parsing spec as possible to make development as easy and bug-free as possible. This is going to become pretty large, but it's pretty cool. Okay, maybe we can do maybe one more thing. We can add something more to it. We'll add some markup here. We'll add a body element, and what do we want to put in there? Maybe a div, right? So let's get to the point where we can parse that. So let's see. Now we're failing. We're after head, and we have a start tag with name body. So you see now what the pattern is for building this parser is you just test something, see where it stops, and you see which state you're in and what kind of token you have, and then you just go to the spec, and you see that we are after head, and we have a start tag whose name is body. So that's one of those things that we asserted on here. So this guy right here. So we'll do this, these steps, insert HTML element, for the token. We need to, actually I didn't do this part fully correctly here. I remember now that there was one more step missing here. We're supposed to reprocess the current token in the new insertion mode. So we'll put a fix me about that so we don't forget. Okay. But for now, we're going to do this body thing. So insert, wait, where are we here? Insert an HTML element for token, set the frame set OK flag to not OK, switch to in body. So insertion mode is going to be insertion mode in body. Frame set OK is going to be not OK. So yeah, see, the frame set OK is OK when the parser is created. It is set to not OK after certain tokens are seen. So starts out true. And then it can become false. Cool. In body insertion mode. Okay, so now we are in body. Presumably we have a div start tag, but we'll take a look. Yes, we are in body with the div start tag. So we have a start tag whose name is start tag whose name is one of these. It's a div. Handle and body. Okay, so and token tag name. Let's do it this way for now because I don't want to write all these out. Or maybe I should. We need a nicer way to say this, but it works for now. Wait, I can't see what I'm doing. Oh, we need a paren. So if the stack of open elements has a p element in button scope, then close a p element. Okay. If stack of open elements has element in button scope. This seems to be a recurring theme. Has a p element in button scope. Is this very, very common? A little bit common. But we have to look into what that means. Maybe we can express it that way. I'm not sure exactly. Close an element p. I'm just kind of guessing what's a good API, and then insert an HTML element for the token. Return. Otherwise, just return. Oh no, assert. So what does it mean to close a p element? Generate implied end tags except for p elements. Oh, close a p element is a thing, right? So close a p element. The stack of open elements is said to have a particular element in button scope when it has that element in the specific scope consisting of the following element types. All of the element types listed above for the has an element in scope algorithm, plus button in the HTML namespace. So listed in the, it's said to have a particular element in scope when it has that element in the specific scope consisting of the following element types. So does that mean that you have this anywhere on the stack? Has that element in the specific scope? have an element target node in a specific scope consisting of a list of blah 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 when the following algorithm terminates in a match state. Start at the bottom of the stack. If you find the target, then you match. Otherwise, if node is not one of the element types in list, terminates in a failure state. So if it is one of these guys, I'm a little bit too tired to figure this out. So I'm gonna put a fix me about this instead. Because it's getting late and I just want to move forward on this. So let's see if we can get this to run. Okay, so now we have an end tag for div. In the in-body state, wow, in-body state is huge. So an end tag is one of these guys. Right, so we can actually do that here. If the stack of open elements, blah, 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 does not have an element in scope that is an HTML element with the same tag name as that of the token. Right, so basically if we don't have such something on the stack with the same exact tag name, let's see how we would work that out. Ugh. Okay, I'm just gonna do this in a sloppy way. Open element if wait. If as element, okay, stack of open elements has element in scope, token tag name. This is a parse error, so assert not reached. Otherwise, run these steps. One, generate implied and tags. If the current node, is not an HTML element with the same tag name, so I guess we can look at his tag name and see if it's not the token tag name. It's the parser. And then we want to pop elements from the stack of open elements until we find one. So while current node, wait, if the current node is not an HTML element with the same tag name as that of the token, then this is a parse error. And then pop from the stack until an HTML element with the same tag name as the token has been popped from the stack. But doesn't that happen right away? Why does it say pop while or until? That's weird. Because Because as I understand it, if at the bottom of the stack, you will just have an HTML element with the right tag name, and then you'll pop it, and then you'll immediately finish. So stack of open elements, take last. I don't see why there would be any point in looping until you find the matching tag name, because we already checked. We literally just checked. But what do I know? We're not going to loop because that would be silly, but maybe there's some nuance here that I'm missing because I am getting very tired. So I'm sure we'll be back here. What does it mean to generate implied end tags? When the steps below require it to generate implied end tags, then while the current node is and that, and this, and that, and this, and that, and that, then you must pop the current node. Okay. That sounds easy enough. So let's see. Generate implied end tags. Okay, and then would be one of these guys again. So long on group option herb earth or earths. And then while the current node tag name while names contains the current tag name, then we will pop off the stack. Stack elements take last. Okay, that doesn't seem so tricky. All right, and then that element and scope thing. I don't know why that one creeps me out. Has element and scope. The stack is said to have an element target node in a specific scope. All right, so I guess we gotta deal with this. The scope is a list of element types. So it's all of these guys. And in our case, it was the... Wait. Have an element in scope. Okay, so it's this list right here. What? Shouldn't it say what kind of scope? Does not have an element in scope. Okay, well, maybe we should make the element stack its own class. Actually, that might be nice, because then it would look a little bit better, but we don't have to do that right now, but it's an idea. So, so this list, applet caption, we're just going to skip over the mathml and svg elements right now. Object template. Okay. actually add this pool. Let's not be const. It's just going to mess everything up. Okay, so initialize node to be the current node, and then we want to iterate backwards in the stack. So I is m stack of open elements, size -1, minus I. All right. Auto node is m stack of open elements at I. Okay, so if node tag name is contained in the list, terminate in a match state, so return true. Otherwise, if node is not, otherwise if node is one of the element types in list. Oh, wait, I'm mixing this up. So if node is the target node, stack of open elements is said to have an element target node in a specific scope. Right, so if it is the target, how can we work this out? So what are you? You are non-null ref per vector. So we can do at, and we'll say target. Right, so if they are one and the same, return true. Otherwise, if node is one of the elements in type list, terminate in failure. Otherwise, set node to the previous entry in the stack of open elements. It will never fail, since the loop will always terminate in the previous step if the top of the stack in HTML element is reached, right? Because we're always looking for HTML. So it will never fail. Sorry, not reached. And then this thing needs to take a target. Oops. But am I really implementing the right functionality now? Because now we're just walking it looking for a target, but I feel like that's not useful for us in that particular context. So we are here, right? If the stack of open elements does not have an element in scope that is an HTML element with the same name as that of the token, so I almost want to like iterate the elements that are in scope. So instead of giving a target, I just want to like get a chance to look at all of them. Or I can also say has element with tag name in scope, right? So I could do that. Tag name. This will be a bit, no, that's okay, I think. So if node tag name is tag name, then we succeed. Okay. This might be stupid, but I'm not sure. Maybe it's good enough right now. So That's what we wanted to say, and then if that was true, then that was a failure, and we should be good, basically. We got a crash. In tag for body, we asserted on 288, so we are here. In body, end tag body. Oh, wait, hold on. We did the div, but now we need to handle in body. End tag body. So where is that? I feel like it's going to be near the end. An end tag whose name is sarcasm. Take a deep breath and act as described in the any other end tag entry below. All right. This thing could have a nicer index. I feel like an end tag whose tag is 1. Hold on. So this is near the head. This is before head. What is this? In head. Can you see somehow which one you're at? End tag whose name is body. This has to be the one. How do I know where I am? Okay, I'm just going to assume that we're in the right place here. In body, yeah, this is the one, okay. End tag whose name is body. If the stack of open elements does not have a body element in the scope, this is a parse error, right? So, I guess this one goes up here. And token tag name is body. If stack of open elements has a body in scope, if it doesn't, then it's an interesting situation. Otherwise, if there is a node in the stack of open elements that's not either this, or that, wait, if there's a node in the stack of open elements that it's not any of these. Oops, I didn't want to go there. Okay, I'm just gonna add a fix me about this because I don't want to write out this logic right now. Holy moly, that's verbose. This should say fix me. Not. And then switch the insertion mode to after body. Then we just need after body. We need to hook that up in our thing up here, so what are we doing after body? I guess we're gonna find out when we crash, see what's remaining. It will just be the closing the HTML tag, I would think. In tag HTML, got it. So right here. Token is end tag, and token tag name is HTML. If it's a fragment parser, but we're not doing that, so we'll ignore fragment stuff for now. Or maybe we shouldn't. Fragment parsing, or just fragment. We'll have a little flag for that. Parsing fragment. Okay, otherwise switch to after body. Okay. Gotta go to the after party. And what, pray tell, happens here? An end of file token, stop parsing. Look at that. That's gonna be us. So end of file. We'll say stop parsing. Okay, I think that'll be pretty cool. Nice note to end on if we can get it to print that out. Oh wait, I forgot to hook that up. And there we are. End of file, although we didn't actually get the statement. Oh, crap. I guess because we do this thing here. Yeah. So what should we do with that? Maybe the tokenizer can remember that he crapped out an end of file. And then if he's already done it once, then we can refuse to do it again. Might be a simple approach here. So eof if m has emitted eof, return the optional. And now we can do that. Oh, we need to actually set that we emitted eof. So here we'll set m has emitted eof true. Look at that. Stop parsing. This is our DOM. Oh man, this is it's a little bit slow, slow development, but you can kind of feel the progress. It's like slow incremental progress. It's pretty satisfying, so I like it. So let's commit this. Implement enough of HTML parsing to handle a small simple DOM. We can now parse this little DOM. HTML I mean, do I really have to spell it out? I guess I can. Because it's kind of nice. Parse parse a little DOM like this. This pretty slow work, but the incremental progress is very is satisfying. Yeah. Okay, so I think this is going to be it for today's video. If you made it this far, then I thank you for watching and for hanging out. I managed to get really tired this time. I don't know why. It's pretty late, and it's kind of intense to like always be following a specification rather than like just hacking up whatever's in my brain. But it's pretty cool too. So I hope that you found this interesting. I think personally I find this really interesting for many reasons, not just like the implementation of it and like what it is, but also like the meta aspect of it, of like implementing a browser and everything around that. Very interesting. So thanks for hanging out, and we'll do more of this. But for now, I'll see you next time. Bye.